Hello all, welcome to Soumya's Tech Talks. In today's lecture, we will discuss on uh, C programming structures and unions. So today we will cover below topics. We will deep dive into structures and unions and guidelines which one to choose between structure and union, and also some real time examples we will see. Let's start. So structure is a user defined data type, like you can create your own data type by using the primitive data types. So it is like you are grouping the primitive data types together. For example, you are creating a data type for employee data. So instead of creating separate variables for employee IDs, names, address and age, you can combine all the data relevant for employee into a structure. So below is the GPS data, like we have declared a structure for the GPS data. Let's discuss on this. So first you see the type def. Type def is a keyword which is used to declare user defined data type. So you are giving type definition, new type definitions. We will be using this type def in many places. Today we will discuss usage of this type def to declare a structure. So you will give type def and struct also a keyword to create structure, and then you open a braces, open brace and close brace, and inside that what are the relevant data. For example, if it is a GPS data, we need latitude, longitude, altitude, like this. You can create all relevant data in the form of primitive data types. Like you can see all these are primitive data types. Here also you can include the user defined data types also, but in this example I only choose primitive data types. So you have a type def, struct and all you will declare, and here you give the name and close. So in this way you can declare one structure. Okay. So you can add more, you can add one more structure inside, one more union, you can add also different data types. We will in the future lectures, once we go to advanced topic, we will be discussing on those topics. So today we will only discuss about basic level of structures. Okay. So once you declare the whole structure, and you have to create objects of it, so variables of it. So how you create, like how you create a variable, integer variable, floating variable, int a, int b, like this. You can give the structure name and variable name, and you can initialize also using the braces, using this curly braces, and give all values in sequence. If you miss anything, you will get the compile error. Also, if you don't want to initialize, just declare it, you can do like this, and later you can write like this, like GPS dot latitude equals to something, longitude, like this you can do. And you want to read it, you can read like this, GPS dot latitude, GPS longitude, like this. So this is how we create structures and create variables of it, and then we will read and write to it. So unions also same, like only difference is memory allocation. If you see the GPS data, you have defined all the members of this GPS data. So for structure, so based on the number of members inside, so total size of all members inside, that much memory will be allocated. But in union it is different. So for example, if you see the GPS data, so when you create a variable of this GPS data, what happens? The memory required to fit all this data, like all these member variables, will be created like this. Okay. So the size of total object will depends on compiler, based on the how compiler allocates. Let's say in some compilers integer is 4 bytes, 32 bits. In some compilers it is 16. So based on that it will allocate. For example, if we here, so all have double is in general it is 4 bytes, so total 16 bytes of data will be allocated. So it will be sequential, like first data for latitude, longitude, like this memory will be allocated. So also sometimes compilers will add the paddings that we will discuss in later lectures. So what is padding? If you see union, it is completely different. Like union, it won't allocate data for all the members. So union in general, it allocates the memory as per the largest data type. Like for example, in this union, let's say BT address, so I have a character array of 6 bytes and integer is 4 bytes in general. So instead of this, uh, instead of allocating for all the members, it will allocate the memory only for one member. That is the largest size. Here the largest size member is data, so which is array of character, which is 6 bytes. So 6 bytes of memory will be allocated and shared by all the members. So this is how the difference between structure and union. We will see how, why the union is like that, how it is useful, we will see. If you see the union, for example, I want to define the Bluetooth address. It is a 6 bytes, but it has some parts like LAP, UAP, NAP, some parts are there. So let's say I want to assign this Bluetooth address from the byte array, but split it into LAP, UAP. Like I want to access LAP from this byte array, NAP from this byte array, like this. So normally if you want to do this, you have to do lot of bit manipulations, lot of code you have to write. But if you use union, it is very simple. Like you have a LAP, UAP, NAP and your data. So you will copy data to here, but you can access each LAP, UAP, NAP simply. Like for example, you can see this code. So here I am calling this function which sets the Bluetooth address using the byte array, character array. So I am this 6 byte character array I am passing to this function. This will set my union, Bluetooth address union, it will set. So while setting, it won't set individually this LAP, UAP, NA, it will directly copy data to this byte array, char data. But while accessing, I can easily access, like BT address.lap, it will easily fetch LAP from this byte array and then give it to you. Like NAP means it is very easy of access. If you don't have this union concept, then from this array you have to do lot of manipulations to get this LAP, UAP, NAP. So that's why the unions are very convenient. Let's say you want to access the let's say you have an integer, you want to access individual bytes, in that case also it is useful. We will see more use cases. The main difference is if you want to use structure, if you want memory allocated for all members, you can use. But if you want create a data from large byte arrays or buffers and split it into smaller types, like we see in case of Bluetooth address. So you can use union and variant data types. Like if you don't know the size of the data, then you can use let's say you have a data type which size is variable and type also changes. In that case we will discuss with an example. So you can use union, and union is mostly used in case of packet decoding, parsing, lot of places. So we will see the with one example. So that let's say here I am combining both structure and union. So the structure is GPS event. Let's say I am getting GPS events from my GPS peripheral. Okay. So first one is GPS event. So the GPS event is nothing but it's a enum. You can see here. It has event power on, power off, fix, lost, GPS error, like this. So first my GPS event will contain the event, what kind of event it is, and followed by the data. So data will be changing as per the event. Let's say power on event won't have any, it won't have any data. Power off will contain reason for power off. GPS will fix will contain all the latitude, longitude. So based on the event, the data will be changing. So for this, what I did, I have created union. Inside that again I have structs. So I have struct for power off event, struct for GPS fix event, like this. So here what happens? So it will define the data for larger message, like for example here the largest message data is GPS fix event data. So you have a event and data will be this much size, but based on the type of event it will change. So you may not use all the data. Let's say you receive a power off event, it only have a reason, so rest of the data is garbage, so you should not access it. So you will check the event and then access it. So like this it is very useful. Let's say instead of having different events and defining lot of structures, the code will be very complicated. But here in this case you will just based on the event you will decode the data. Okay. Let's see how we can encode and decode the event. So to encode, let's say you want to send a GPS fix event. So you want to send a GPS fix event with this latitude, longitude. So I will just create GPS event and assign event to GPS fix, and then data I will copy and then I can send it. So here at the last I can call the function to send the event. Okay, like this you can create simply. So if you don't have this this setup, then you need to do lot of things for encoding. So the encoding is very simple. So we will see the decoding also. So if you see the decoding, it is very simple. Let's say I have a function called handle GPS event. First I will have a switch case for event. If it is power off, I will only access the data of power off, because rest of the data is invalid. If it is GPS fix, I will access only GPS fix data. Like this, if you combine the structures and unions together, you can easily write your applications in very simple and readable and also maintainable code you can write. Okay. So today's we will end today's lectures, and next lecture we will cover bit fields, structure paddings, advantages of paddings, why it is needed, and how to force the compiler to avoid paddings, and all the things we will discuss. Thanks for watching. Bye for now.